Hello. Welcome back again to my class. My name is Amara. I am the physics teacher on Akada Store, and today we are continuing our investigation of the topic electrostatics. We've been on this now for a while. We have a few simulation before this, okay, but today we'll be investigating this formula here. F equals K Q1 Q2 over R squared. This is actually Coulomb's law. The scientist that proposed this formula, his name was Coulomb, and so the formula was named after him. It's called Columbs Law. So we'll be investigating this today to find out if what we are told theoretically is actually true. Now remember, all questions and answers, all discussions, assessments and tests, all those ones are given on Akada Store platform. So you sign up there and then you get it there. So let's immediately start up our investigation. Some definitions before we start up. A variable is anything that can be changed or manipulated. We have two types of variables: independent variables. Now these ones are the ones that the scientist deliberately changes. Okay, this one the person deliberately changes or manipulates a particular figure. These ones are the independent variables. Now, the dependent variables are the variables that depend on the independent ones for their values. It means these are the ones that get observed, these are the ones that get measured, these are the ones that you collate data on. So these ones change as a result of the independent variables changing. Now, as we go forward in this simulation, I'd want you, that's part of the questions I'll be asking, I'd want you to identify for me which ones in this simulation will you label as the independent variable and which one will you label as a dependent variable. Now, based on our formula, F equals Q1 Q2 over R squared, where R is the distance, Q the distance between the two charges, Q1 and Q2 are the charges that we are testing. Okay, so these are the two charges here. Now, for this first one, I'm using two unlike charges. That's why you can see minus mu coulomb and plus 3 coulomb, mu coulomb here. Okay, you look at the force, you see what happens. So in the first instance, I'm going to keep one thing constant and then vary the other one. Remember, during an experiment, you only change one thing at a time. Then you collate your data or the result on the other things that happen. So we only change one thing at a time and then we'll see what happens. So the first one I'm going to do, I'm going to keep the distance between these two objects constant. I'm not going to touch it. I'm going to keep it constant. There's like 5 cm between them, right? Then I'm going to vary the charge, the value of the charge with these two charges. I'm just going to pick one and I'm going to vary. So what you're going to do is you watch the value of the force, because whatever happens, we'll check if there's an effect on the value of the force. Okay, so first of all, I'm going to increase this. This is minus 4 mu farad. I move it to 5. Watch the force. I move it to 6, 7, 8, up till 10. What happens? What's your observation? Now, I'm going to move this back to 0. At 0, what happened? Everything, the force acting on these two at 0 is now 0, right? Because one of the charge is 0. Okay, so what I want to do actually is to make them the same. So I'm going to move it this way. So this is now 1 mu farad. Okay, so let's do it this way. This is 2 mu farad. This is 3 mu farad. And this is the force between them right now. If I move this back, and remember these ones are two like charges, okay, two like charges, and the force here is 18.493. Now I'm going to move this back. I'm going to change this to be a negative charge but of the same magnitude. All right, so this is minus 2 mu coulomb, sorry. What did you observe? Okay, look at the force. Was there a change in the force from the very first, the first one I showed you, or not? Okay, so you write this down. Now, the next thing I'm going to change and manipulate is the distance between these two charges. So I'm going to keep the value of the charges constant, and then I'm going to vary the distance, and let's see what happens. Now, as I move it from, remember it's at 5, so okay, to make it easier for you to see, let me put it this way. Okay, it's at 5 now. Right, so I'm going to, first of all, I'm going to move them away from each other. So from this 5 to 6 here, watch the force. What happens to the force as I move away from it? What happened up until this point? Now, let me start coming. Let me bring it closer. I bring it close and close and close. Watch the force. And then watch that these arrows are coming out. What do you think these arrows stand for? What do they represent? Watch. See? What do these arrows represent? That's a question. Okay, so we've done this. Now let's also check something else. I'm going to leave this here because of these arrows. I want us to also check something. I'm going to increase the magnitude of the charges. So let's see if there's any difference on these arrows. I'm going to increase this to watch the arrows. Watch the arrows. See? What did you observe? What do you think? I'm still increasing it. I'm still increasing it. What do you actually think this arrow stands for? Now, let me move it to the other direction. This is 8 and 9. Let me move this to positive 8. Let's see what happens. You see what happens? You see what happens? So, what do you think? How do you explain what is happening here, what you're observing here? Now, so these are the following questions I want you to answer. Identify the independent variable. Identify the dependent variable. What does this arrow, what do they stand for? Okay, then what was your observation when we changed the magnitude of one charge? We changed its direction. We made it from positive to negative, but the same magnitude, the same size, but different direction. What was the effect on the force? I want you to let me know based on what you observed. What do you think happened, and how do you explain that? Then these ones I want you to tell me true or false, but as you're telling me the true or false, also now as I'm asking you this question, I expect you to think critically based on what you just observed. Don't guess, don't assume based on your observations in this simulation. What do you think? What is your so as you think you're giving me evidence, you're giving me reason based on the simulation you just watched now or we just did together. If I say Coulomb's force of electrostatics that it can be changed. Is it true or false? Why do you say that? Is it true that the bigger a charge, the bigger the magnitude of a charge, the smaller the force? Is that true or false? And then finally, is it true that the smaller the distance, the bigger the force? And with all those questions, when you answer it, you now look at the formula I showed you at the beginning of the simulation. Then you compare, does it actually answer that question? Does it actually fall? Is it in line with that formula? The theory that we've seen and this practical, is it in line with it? So these are the questions I want you to answer. You can you can watch the simulation over again too, if you need to, so that you can get some of those points. And then let me hear your view. Like I said, my discussions and questions, answers, whether it's test I'll be sending you, all of them will be done in a Akada store. So you go there, you pick it up. Thank you.